Welcome to this exciting video where we will guide you through the installation of RabbitMQ, one of the most powerful and widely used message brokers in the industry. Whether you're new to RabbitMQ or looking to expand your knowledge, this video is designed to provide you with a comprehensive understanding of various installation methods. We will explore three popular installation approaches: Docker Compose, Kubernetes, and Helm. Each method offers its unique advantages and caters to different deployment scenarios. By covering all three methods, we ensure that you have the flexibility to choose the installation approach that best suits your needs. First, we will walk you through the Docker Compose method, which provides an easy and efficient way to set up RabbitMQ in a containerized environment. We will guide you step by step, explaining the necessary configuration and highlighting key considerations along the way. Next, we will dive into the world of Kubernetes, a powerful orchestration platform. You will learn how to leverage Kubernetes to deploy RabbitMQ using manifest files, ensuring scalability, fault tolerance, and high availability. We will explore concepts such as pods, services, and persistent storage, enabling you to confidently set up RabbitMQ in a Kubernetes cluster. Finally, we will explore the Helm method, a popular package manager for Kubernetes. Helm simplifies the deployment and management of complex applications like RabbitMQ by providing a templating system and streamlined release management. You will witness firsthand how Helm can accelerate your RabbitMQ installation process while maintaining configurability and flexibility. Before we proceed, make sure you have the following in place. Docker. Docker is a containerization platform that allows you to package applications and their dependencies into isolated containers. Ensure that Docker is installed and running on your host machine. Docker Compose. Docker Compose is a tool that simplifies the management of multi-container Docker applications. Verify that Docker Compose is installed on your system. Docker Engine. Docker Engine is the underlying technology that provides containerization capabilities. Make sure Docker Engine is enabled and running on your machine. Docker Hub account, optional if you plan to use a customized RabbitMQ image. Create an account on Docker Hub. Docker Hub is a public repository where you can store and retrieve Docker images. YAML configuration file. Prepare a YAML configuration file that defines the RabbitMQ service. This file will specify details such as port mappings, volumes for data persistence, and environment variables for configuration.
Let's now take a look at some common Docker and Docker Compose commands that will come in handy during the management of containers. For Docker. Docker pull image. This command pulls an image from a registry, allowing you to download it locally. Docker run image. This command runs a container based on the specified image. It creates a new container instance from the image. Docker PS. This command lists the running containers on your machine. Docker stop container. This command stops a running container. Docker rm container. This command removes a container from your system. Docker images. This command lists all available images on your local machine. Docker rmi image. This command removes an image from your local machine. For Docker Compose. Docker Compose up. This command builds, creates, and starts containers defined in the Docker Compose file. Docker Compose down. This command stops and removes containers, networks, and volumes defined in the Docker Compose file. Docker Compose start. This command starts existing containers defined in the Docker Compose file. Docker Compose stop. This command stops running containers defined in the Docker Compose file. Docker Compose restart. This command restarts containers defined in the Docker Compose file. Docker Compose PS. This command lists the running containers defined in the Docker Compose file. Docker Compose logs. This command displays the logs from containers defined in the Docker Compose file. These commands will be helpful for managing your containers and orchestrating them using Docker and Docker Compose.
I will be explaining how to install RabbitMQ using Docker Compose. Docker Compose simplifies the installation and management of RabbitMQ by utilizing a YAML configuration file. With Docker Compose, we define the RabbitMQ service in the configuration file. Let's take a look at the configuration. The configuration file installs RabbitMQ using the latest official RabbitMQ Docker image. It maps the AMQP port 5672, and the RabbitMQ management UI port, 15672, from the container to the same ports on the host machine. This allows us to access RabbitMQ from our local system. Data persistence is ensured by binding a directory on the host machine to a directory inside the RabbitMQ container. This means that even if the container is stopped or removed, the data will persist. Environment variables can be set to configure the default username and password for RabbitMQ management and authentication. Make sure to replace your _username and your _password with your desired credentials. Once we have our configuration file ready, we can run the command docker compose up in the same directory as the docker compose file. This will start the RabbitMQ container based on our configuration. After the container is up and running, we can access RabbitMQ through the specified ports on our local machine. Additionally, the RabbitMQ management UI can be accessed via a web browser. That's it. Now you know how to install RabbitMQ using Docker Compose.
Let's explore the process of installing RabbitMQ using Kubernetes. Kubernetes provides a powerful platform for deploying and managing containerized applications like RabbitMQ. Here are the steps involved. Set up a Kubernetes cluster. Begin by configuring and setting up a Kubernetes cluster. This can be done using tools like Minikube for local development, or managed Kubernetes services like AKS, GKE, or EKS for production environments. Create a RabbitMQ deployment. Define a deployment manifest in YML or JSON format. Specify the RabbitMQ container image, the desired number of replicas, resource requirements, and other relevant settings. Expose RabbitMQ service. Create a service to expose the RabbitMQ deployment. This allows other components or applications within the cluster to connect to RabbitMQ. Configure persistent storage. Set up persistent volumes and persistent volume claims in Kubernetes to ensure data persistence and durability for RabbitMQ. This ensures that RabbitMQ data is retained even if containers are restarted or rescheduled. Configure access control. Establish appropriate RBC, role-based access control, rules and permissions to control access to RabbitMQ resources. This ensures that only authorized entities can interact with RabbitMQ. Monitor and scale. Leverage Kubernetes' built-in monitoring and scaling capabilities to monitor RabbitMQ's performance and scale the deployment as needed. Kubernetes provides features such as automatic scaling, high availability, and rolling updates, making it an ideal choice for running RabbitMQ in production environments. By following these steps, you can effectively deploy and manage RabbitMQ using Kubernetes, taking advantage of its advanced features and scalability. Let's now explore some fundamental concepts in Kubernetes that play a crucial role in deploying and managing applications. These concepts are pods, services, and persistent storage. Pods serve as the fundamental unit of deployment in Kubernetes. They encapsulate one or more containers and provide an isolated environment for running applications. By grouping containers together within a pod, we can ensure efficient resource allocation and management. Services, on the other hand, enable communication and connectivity between different components within a Kubernetes cluster. They act as a stable network endpoint, providing a consistent interface for other services or external clients to interact with pods. Services enable load balancing, automatic service discovery, and facilitate seamless communication between pods. Persistent storage is a critical aspect of managing stateful applications in Kubernetes. It ensures that data remains intact even if pods are restarted or rescheduled. Kubernetes provides various mechanisms, such as persistent volumes and persistent volume claims, to manage and provision storage resources for pods. With persistent storage, we can ensure data persistence and availability, even in dynamic environments. Now let's move on to step 1 of deploying RabbitMQ with Kubernetes, creating a deployment manifest. To create a deployment, we need to define a deployment manifest in YML format. Here's an example of a basic RabbitMQ deployment manifest. As shown on the left side of the slide, we have the YML code specifying the deployment configuration. In this manifest, we name the deployment as RabbitMQ deployment and set the number of replicas to 1. We use the official RabbitMQ Docker image as the base for our deployment. Additionally, we expose the container ports for AMQP 5672 and the RabbitMQ management UI 15672 to allow communication with RabbitMQ. Once we have this deployment manifest ready, we can move on to the next step. Moving on to step 2, applying the deployment manifest. To apply the deployment manifest and create the RabbitMQ deployment, we use the kubectl apply command. As shown on the slide, you can see the command kubectl apply f-rabbitdeployment.yaml. Running this command in your terminal or command prompt applies the deployment manifest specified in the YML file. It creates the RabbitMQ deployment and starts the number of replicas defined in the manifest. With this step completed, RabbitMQ will be up and running in your Kubernetes cluster, ready to handle messaging and communication. Now, let's proceed to the next steps of exposing the RabbitMQ service. To expose the RabbitMQ service, we need to create a service manifest. The slide shows an example of a basic RabbitMQ service manifest in YML format. In this manifest, we define a service named RabbitMQ. It uses a selector to match the deployment labeled with app, RabbitMQ. The service maps the container ports to the same ports on the service, allowing access to RabbitMQ. Once we have the service manifest ready, we can apply it using the kubectl apply command. The command kubectl apply f_rabbitmq_service.yaml applies the service manifest, creating the RabbitMQ service in the Kubernetes cluster. With the service created, other components within the cluster can connect to RabbitMQ using the service's endpoint. We have now completed the steps for deploying and exposing RabbitMQ in Kubernetes. RabbitMQ is up and running, and it is ready to handle messaging and communication within the cluster. Let's discuss how to install RabbitMQ with Helm, a package manager for Kubernetes that simplifies the installation and management of applications. Helm provides Helm charts, which are pre-configured templates for deploying applications. RabbitMQ has its own Helm chart, making it straightforward to deploy RabbitMQ in Kubernetes. Here are the steps to install RabbitMQ with Helm. First, install Helm on your system. Helm has a simple installation process that varies depending on your operating system. Next, add the RabbitMQ Helm repository to Helm. This repository contains the RabbitMQ Helm chart that we'll use for installation. After adding the repository, update the Helm repositories to ensure you have the latest charts available. Now you're ready to install RabbitMQ. Use Helm to install RabbitMQ using the Helm chart. Helm will handle the deployment and configuration of RabbitMQ based on the charts template. If needed, you can customize the RabbitMQ configuration by modifying the configuration values in the Helm chart. This allows you to tailor the deployment to your specific requirements. Finally, verify the RabbitMQ installation by confirming that it is successfully deployed and running within the Kubernetes cluster. With Helm, managing RabbitMQ becomes much simpler. Helm facilitates easy updates and configuration changes, making it a convenient tool for managing applications in Kubernetes. Helm install is the Helm command used to install a chart and create a release in Kubernetes. MyRabbitMQ is the release name, which you can customize to a name of your choice. It serves as an identifier for the specific installation of RabbitMQ. Stable/RabbitMQ refers to the RabbitMQ Helm chart that will be used for the installation. The stable repository contains a collection of curated charts, and RabbitMQ is the specific chart for RabbitMQ provided by the Helm community. Once you access the management console, you will be prompted to log in. Use the credentials you have configured during the installation process. In the management console, you will find various tabs and sections that provide information about the RabbitMQ instance. This includes details about exchanges, queues, connections, and more. By exploring the management console, you can verify the status and functionality of RabbitMQ. Ensure that the necessary exchanges, queues, and connections are set up correctly.